Good morning guys. We're back at it again with another video. So last one that I posted would have been finishing off all the plumbing inside of the rainwater pump house there. Today's video we're going to go over the entire electrical system and what we're going to be doing inside of it. So if you remember from the video that I posted doing the concrete slab, you would remember that there is a piece of 1/2 inch PVC conduit that is coming up just inside the wall right there. So we're going to be tapping into that because that connects to our main electrical panel right there. We're going to be pulling over a couple circuits. We're going to be pulling over a double pole circuit for the pump. So we're going to be running it at 240 volts. And we're also going to bring over 220 amp circuits. I'm going to mount 2 outlets inside of the pump house. And then I'm also going to mount 2 on the exterior of the building there. So when we're building our main house, which is just going to be right down there, we're going to have easy access to some 20 amp circuits and just be able to run some extension cords down there. We're going to mount a little light in there. And I think the next thing that we got to do is just jump right into it.
Ooh, baby, here we go. So first thing that we're doing is trimming off that 1/2 inch PVC conduit, and then we're attaching a 1/2 inch female adapter already with our 1/2 inch EMT connector in it and getting that going. So I show a lot of conduit bending in this video. I'm not going to go into too much detail about how I actually do it, just because there's so many videos on YouTube about it. But we have to get an offset coming from that PVC conduit going to a 4-inch switch box / junction box that's going to be going just to the left of the door there. So now I can see that my offset is too much, so I can go back and take out some of those offset bends and try to get it to where I want. And again, wasn't exactly where I wanted, so we got to go back and just slightly take out some of the bends there. For certain offsets like this, I just eyeball it and I just kind of just do it by feel. You can get very precise with it, and there are measurements and there are ways to do a very, very precise offset. But for some of these bends, it's just easier just to get up there, bend it, and then fix it. And just kind of do it like that. Now what I'm doing is, since I'm happy with that offset, is that I'm putting a box offset on the end of that piece of conduit there going into our 4-inch square box. So now that I'm happy with the offset and the box offset going into the 4-inch square box, we can tighten down all of our set screws, and you can just use a magnetic level on the side of the EMT conduit just to make sure that that conduit's going to be going nice and plumb. Now, next thing that we're going to be doing here is running a piece of conduit going over to where the 240 volt switch is for the pump. So this is how we bend a 9D into some EMT conduit. I already have the box offset on the one end there going into the 4-inch box. And now what I'm doing is I'm putting a slight kick or a slight bend to bring that conduit so that it matches right up to that wall there. So you'll kind of see how it goes together right here. And now I can see my offset or my kick is not enough, so I can go back and just give it just a little bit more of a kick there, just to make sure that everything is going to be running up and down. Very nice. So you can see just a little bit more kick. It brings that vertical piece of the conduit a little bit more plumb to the one right beside it there. Happy with that. We can get our straps in, and it's really nice and handy when you're running conduit over a distance like this, is just to use your laser level so that it's going to be nice and level, and it's going to look the best that it can. So it's really important here that we're tightening down all of our set screws on the couplings on any of the connectors, because we're going to be carrying the ground through the conduit here going to the box. So in certain circumstances, it's mainly if you're running plugs for, hospitals and certain types of special equipment that you need to run an isolated ground through a conduit. But code basically says that you can run your ground through the conduit there, so it just saves having to run one extra wire in there. So we've got our next piece of conduit going to the 4-inch box here, and again, tightening down all of our set screws. It's super, super important. And we can get a couple of screws going into the box there, and then we can get it that conduit strapped up there, and then we are looking good to go for this piece of conduit. So now I'm bending a piece of conduit that's going to go up from that 4-inch box over the door. So I'm just showing you that on the bender there are arrows. So I know that I need a 30-inch stub out going from the top of the 4-inch box so that that conduit goes up to the door there. I already bent an offset or a box offset on the end, then that's in my left hand right now. And then we're just going to bend that 90 into it just to go over that door. You can also, if the offset or the bend isn't perfect, you can actually just kind of fix it up just by bending it by hand there. And once I'm happy with that, then we can get it mounted, we can get it plumbed up and going around the door there. And then we're going to bend one more piece here, going around the corner and then to a light that we're going to mount on the wall there. Again, you can use your magnetic level there if you don't have a laser level, just to get things nicely plumbed up. So I already bent a 90 and a kick into this, and now I'm just trimming it to where it needs to go. This is a really important tip for bending conduit. So you can see all the burrs on the inside of that conduit after you make a cut. So if you're using a power saw like this, or if you're using a hacksaw, you're going to have those burrs on the inside. Once you run your pipe reamer through it, or your conduit reamer, and then it cleans that up and basically prevents when you're actually pulling the wires through the conduit, the wires aren't going to be digging into those burrs. So now I'm just making my final box offset, which is going to go into our light box, just making any adjustments to it, and it is looking real nice. It's very satisfying to bend conduit nice, have it look really good. It gives a nice, clean, professional look. And I wanted to, so you notice in the back corner there that the conduit kicks down a bit, and that's because I knew that I would have to run my 3/4 inch copper line right above it. And with the light box and the size of the light box, I wanted to bring that conduit down just a little bit so that I can sneak that copper line above it there. So we've got everything mounted there, and now we can mount our little light box. So this is just like an anti-vandal light that I just got on Amazon for I think like 20 bucks or something like that. It just kind of looked cool and kind of went with the motif inside the shed there. So once we've got that mounted, now I want to get basically an area here, or I want to mount the box to the outside of the building so that I know where it's going to be popping up inside, because I'm going to be tying the 4-inch box on the inside to that light box that I just mounted. So we're going directly right through basically where the purlins are, going horizontally across the building, so I can screw into that wood, and that outdoor box is not going to be going anywhere. So I'm sticking my long bit going through there just so that I can pop out on the inside of the plywood there and just kind of see what's going on. So we're going to be taking a 4-inch box and we're mounting a BX connector to the back of it, and that's actually going to sit inside the wall there. So everything's going to be really clean and really flush. At the end of basically a BX connection like that, where you cut the wire, you need to have one of those red insulating kind of washer type things. I forget what they're exactly called. I should really know what it's called. But once we get that screwed in and we get that tightened up, then we can screw that outdoor box right to the building there. And I like to say that I'm making these things Hannah proof, aka my wife Hannah, so that none of this stuff can get pulled off the wall, because I give her shit for one of the spigots that I have on the tiny house because it's almost fallen off the building there. But anyways, all right. So there's many different ways of cutting or basically splicing up BX wire. This is just kind of the method that I learned. So I definitely want to trim and get rid of the casing that's going around the wires there. And again, we have to use one of those red insulating, God damn it, I just cannot remember what they're called for the life of me right now. Anyways, they got to go in there. And then we get the wire coming from the outside box going through the back of the inside box here. And I had to go through one of the holes that wasn't dead center because I wanted to get the 4-inch box a little bit further to the left there, so that I could run basically a piece of conduit straight from the top of that box up to the light box there. And as Jimmy DeResta says, for a lot of this stuff, if it looks straight, it definitely is straight. So now that I've got the next piece of conduit already bent, there's this 2 box offsets on either end. We can just slide it up into place, making sure that we tighten down all of our set screws, because again, we're carrying our ground wire going through all these metal boxes here. You can't carry the ground going through a plastic box because it obviously is not going to conduct electricity, but with the steel boxes there, you can carry the ground going through it and carrying it through the conduit. So One thing that is a little bit different to the boxes that you buy in the States here is that they don't have any ground screws, so you actually have to buy ground screws separately. I don't know, it just seemed different because when I was in Canada, I never bought specifically ground screws. They're already in the box, in the 4-inch boxes. Things are a little bit different in the States here. So you got to buy some ground screws. I tailed off 1 ground wire to 2 ground wires because we're going to have 2 receptacles there. So we want to get both of those, obviously both of those receptacles grounded up. So once we have the grounds done, we can start working on the neutral here and getting that tailed off. So we're bringing a neutral down. There's only one neutral for these 2 circuits. So when you have basically 2 20-amp circuits and they're both under a double pole breaker, which is very critical for this to basically follow code, is that you can share the neutral between both of those circuits. So instead of having a black, a red, and 2 whites, you only need a black, a red, and 1 white. So it just saves on obviously running extra wires and having those fill up your conduits there. So there's little tricks like that that electricians know in order to minimize obviously how much a project costs and how much wires we have to run and all that kind of jazz there. So now that we've got the green tailed off, we've got the white tailed off with 2 tails. We've got 2 tails on both of them. We can start wiring everything up, and we've got our black and we've got our red already situated there. So when you're wiring up receptacles, when you're wiring up pretty well everything, you should follow the same order of action. You want to wire up the ground first, and then the neutral, and then any hot wires. So that's just more of a really good habit to get into. If you're to ever wire up anything live, which you don't need to do for the 99% of residential and commercial installations, you don't have to deal with live wires, but you definitely want to make sure that you're following that order of action. It's just a good habit to be in. Now that we've got basically the ground wire connected to the bottom of the receptacle, we've got the neutral tails wired up to each of the receptacles, we can now attach our 2 hot wires. So each receptacle is going to be its own 20 amp dedicated circuit, and then the extra red and the extra black that we're attaching to these receptacles is sending power to the outdoor receptacles. So that's kind of how this is working and how this is all kind of happening inside of this little box here. It's kind of hard to explain exactly how everything goes, but some important details here is that we are using 20 amp receptacles, so there's a difference between 15 amp receptacles and 20 amp receptacles. When you're using one of those raised cover plates, you got to take out the 632 screws, which are at the top and the bottom of the receptacles there, or else it doesn't work. And then there's also these little ears on the top and the bottom of the receptacles, which you have to bend and get those off as well. So now we can attach our receptacles right to that raised flush cover plate, or to that raised cover plate, and then screw it right back into the box there. So now I can start working on the 240 volt switch for the pump there. So when you're basically taking off the insulation or the plastic coating around a power wire like this, so this is 12-3 power wire, you got to be very careful that you don't dig your knife into the actual wire itself, and you're just lightly scoring the outside and then pulling on the part that you want to remove, and then it does typically separate pretty easily there. So again, with this setup here, we're going to have to put in a ground tail to be able to connect to that power cord there. So this is a 240 volt switch. You've got your leads for basically the hot side. They go on one side, and then the switch side goes on the other side, and the screws are color coded. So you want both your feed in going, I believe, to the black side there. I think that's what I'm doing, but it actually will state right on the switch which side is the feed and which side is the switch side of the switch. So with some of these switches, you don't need to curl the ends of the wires. You can just put them straight in there, and there's just like a little pressure plate in there that basically secures the wire to the switch. But the nice thing about wiring up things that are 240 is that you can't really mess it up. You got 2 hots coming in, and it doesn't matter which side hooks up to the other side or anything like that. You can't really mess it up. So that's one benefit of wiring up things with 240 volts, is that you just got 2 hots, and it doesn't matter which one you hook up, because they're both supplying 120 volts. Once we got that wired up, we can put the cover plate back on and get her all done. Now on the side of the pump troll here, there are some 1/2 inch knockouts there, so we're just using some 90-degree angle connectors going into the side of the pump troll controller. So on my last video, I basically had to override the settings on the pressure switch, which is on the pump. When I ordered the pump, I totally forgot that there's a pressure switch on it, but I much would rather have everything run from the pump troll here, which is what I'm wiring up. It's definitely going to be much more robust and is going to be a better quality product over time for switching the pump on and off based on the pressure here. So again, lightly scoring around the outside of the wire there, and then pulling off the insulative jacket on it, and then we can get our wire going into the pump troll, and then we can get our angle connector here all finished off. And now that we've got the wire in there, again, first thing that we're going to wire up to the pump troll is going to be the ground. And just because there's a little screw back there, we've got to curl it around there. So at the end of the green wire, you can tighten up that stranded wire and then put a curl on the end of it. Inside the pump troll, it'll basically tell you a schematic how you should be wiring it up, because there is a feed side and a load side. So you just want to make sure that you have your feed side on the correct side there. Now, some guys might be like, well, you're using a white to carry a hot. I guess, I don't know if this is against code. I think if to make it code compliant, what I would have to do on that white wire there is just add some tape to it. But since I'm the only one dealing with this, I know that they're both hots and that it's both a 240 volt circuit. So now we can run basically the load wire, which is going to be going directly to the pump, so we can put it into the other side of the pump troll there and get it wired up to the pump troll there. So again, we want to get our ground wired up there first, and then we can wire up the two basically the two hot wires that's going to be going directly to the pump. So coming from the pump troll, we want to loop our two wires together, and just using some zip ties to keep the cables nice and clean and nice and slick, and following some straight lines here. And now on the shallow well pump, we've got our feed wire coming in there, so you can just see it dangling down there. And on the inside of the pump, it'll basically tell you exactly how you should be wiring it. On the back of the pump is a 120 240 volt switch. So those Wayne shallow pumps, they come in wired for 120 volts, but there's a little switch on the back. It's a little white thing that you pull out and then switch it over to 240. You definitely want to be doing that, because if you don't, you'll be sending 240 volts to a well pump that's wired for 120, and it'll probably just start smoking, or it'll just probably blow up. So that 12.3 power cable that the guys cut for me, if they actually cut me the 14.3 stuff, it would have fit inside that cable gland. So I just had to replace it with another one of those angle connectors, so we can just get the wire going nice and clean and straight into the side of the well pump there. Again, there's going to be a ground wire in there that we have to hook up our ground to. And then we've just got our black and our white there, which are both 120 volt leads. Again, you should probably tape the end of that white wire. All right, guys, so just a quick overview of what we did there. We've got our main 1/2-inch conduit coming into this 4-inch box. So we've got a light switch, which controls that guy right there. And then we've got a conduit coming around with two 20 amp circuits. So we've got a couple of 20 amp receptacles right here, which are not necessarily going to be in use 100%, but I might put garden equipment in here, so if we ever need to charge batteries or whatever, then we can do that right there. And then coming outside to the outdoor box, we've got a couple of 20 amp GFCIs. So that'll be great, especially because we're going to be doing construction on the new house right there. So we've got a power source, we've got a water source right here that is going to be easy access for what's going on right there. And also coming out of that box, we've got two hots for a 240 circuit. So we've got a 240 switch right there that we can just switch on and off. So the guys at the hardware store accidentally cut me 12.3 instead of 14.3, but you can always go up in wire, that's not a big deal. Come up with our little angle connectors on either side there. You could also probably use BX, but I wasn't sure if the BX would have any kind of issues with touching the bare copper there. So we come down and then it's wired right into the pump there. All right, guys, that is a wrap for the electrical portion of this. I hope you guys learned something, especially with bending conduit in this video. I think it's really worthwhile to learn how to bend conduit. It's not that tricky. There's lots of really good informational videos on YouTube about how to bend conduit the proper way, how to make sure that your stub ups and all your bends are going to be
as precise as you need them. And one really good thing about running conduit is that you can always add in more wires later, or you can rewire things a little bit easier if you need to. So that's one reason why, especially in a mechanical room like this, it's really nice to be able to run conduit, just because then you're not limited by either the size of BX